Going on to page 4-7, we're continuing to graph sine and cosine functions. In example 4, we're going to graph a sine function. So we start off by finding the period. This is 2 pi over b, and in this case b is 3. So that's our fifth key point. And now we need to find the other ones. We have 0, 0, and then 2 pi over 3. Now halfway between that is half of 2 pi over 3, which is pi over 3. And halfway to pi over 3 is pi over 6. If you're having a hard time understanding that, we can write off to the side. Half of something means 1/2 times it. So half of pi over 3, just multiply straight across and we get pi over 6. To figure out the fourth key point, we can think of this as adding pi over 6 each time to get there. So we have 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6, that reduces to pi over 2, and then 4 pi over 6 is our final key point. If that's too confusing, you can take half of the sum of pi over 3 and 2 pi over 3. That's half of 3 pi over 3, and that reduces to pi over 2. So 3's divide out. Now for sine, we know that it starts at 0, 0. Then to find how high and low it goes, we find the amplitude. Well, the amplitude is the absolute value of a. Well, a is -2. So that means that we're going to go 2 units up from the middle and 2 units down from the middle. Now we see that there is a negative, and so that negative means that it's going to be reflected across the x-axis. So instead of going up and then down, we're going to go down and then up. So what I'll do is graph the function before it's reflected and then the final function after it's reflected. So for sine, we know that we go up, then down to the middle, to the minimum, and then back to the middle. I'm going to make this dotted. But the final graph has a -2 instead of a +2, so that's where we're taking just the opposite values of y. So instead of going up, we're going to come down, back through the middle, up, and into the middle. So this is one period of the function y is equal to -2 sine of 3x. Going down to example 5. Now we're going to graph y is equal to a cosine of bx. Starting off with a period. This is 2 pi over b, and in this case b is pi, so this is 2. So we'll mark our fifth key point as 2. And then for the other key points, we take half of 2, which is 1. Take half of 1, which is a half. And then we can think of this as 1/2. 2 halves is 1, and this would be 3 halves, and 4 halves, which is 2. The amplitude is the absolute value of a, which is -3. So the amplitude is 3. It means that we're going to have a maximum of 3 and a minimum of -3. And then do you see how there's a negative that's in front of the 3, and that means that it's reflected across the x-axis. I'm going to start off by graphing the cosine function as if a was positive, and then I'll reflect it after that. Remember how cosine looks. Remember we start off from the maximum and then we go down to the minimum and then back up. So we'll do that here. Start off at 0, 3. The middle is at 1/2. then down to the minimum, middle at 3/2, and then the maximum. I'll draw this dotted line since we're just going to use this to help us to graph the final graph. Now we're going to reflect this across the x-axis. We'll start off at 0, -3, then 1/2 0, 1 3, 3/2 0, and 2 -3. Now it's at 0, -3, we know that's the minimum, so it's going to come back up. Come up to the maximum and then back down to the minimum, and then it goes up. So you want your arrows at the ends to go up, and that is one period of y is equal to -3 cosine of pi x. On the next page, 4-8, we have example 6. Now we're going to go backwards, starting off with a graph. We want to find the equation. First, I'm going to determine if this is sine or cosine. If it starts at 0, 0, then it's going to be a sine graph. And you see how this one doesn't. It starts at the minimum and then it goes up to the maximum and back down. So that means that this is going to be a cosine graph. Now we know that the period is 2 pi over b. And for this graph, you see how far it goes before it repeats? There's just one period that's graphed, and that's from 0 to 4 pi. And then it's going to repeat after every 4 pi. I'm going to replace the period with 4 pi is equal to 2 pi over b, and then solve for b. I can multiply both sides by b, so we'll have 4 pi times b is equal to 2 pi, and then we can divide both sides by 4 pi, and so we have b is equal to 1/2. And then for the amplitude, well, that's halfway between the minimum and the maximum. And just looking at the graph, do you see how that's 2 units away from the middle to get to the maximum and to the minimum? We can also come up with the amplitude using an equation. The amplitude is 1/2 of the distance between the minimum and maximum. So I can just take the maximum minus the minimum. So we have 1/2. Maximum is 2 minus the minimum, which is -2. That adds up to 4. So 1/2 of 4 is 2. The absolute value of A is 2. But then, do you see how it's reflected across the x-axis? And since it's reflected across the x-axis, that means that it's going to be -2 for A. So A is equal to -2. Now I can write my equation. We have y is equal to A, which is -2, cosine of b, which is 1/2, times x. Sine and cosine functions can be used to model real life where the values are repeated in a cyclical or periodic manner. Here's an example. We're given an equation that models the average temperature in Mould Bay, Canada. We're not going to graph this equation since we're not using graphing calculators for this class, but I'd like to instead write out some information that we can tell just by looking at the equation. First of all, there's something that's a little bit different we haven't seen before, and we have this -4.3. We're going to see that in the next section that deals with the phase shift, or the shift to the right or to the left. For this equation, you can see that we have this -4.3, and that's a little bit different than we've seen before, and that's describing the horizontal shift that we're going to be working with in the next section. But for now, let's determine what the period is. A period is 2 pi over b, and in this case b is pi over 6, because it's the coefficient of x. Same thing as 2 pi times the reciprocal of pi over 6, which is 6 over pi. The pi's divide out, so we're left with 2 times 6, which is 12. This means that it repeats after every 12 units. X describes the number of months, and here we have 12 for the number of months. The amplitude is the absolute value of A, which is the absolute value of 34, and that's 34. And what does that mean in this case? Well, the average temperature in this place in Canada has a high of 34 and a low of negative 34 degrees. Part B. According to this model, what was the average temperature during the month of May? Well, if x equals 1 corresponds to January, May is the 5th month, so for this one we're going to find f of 5. So 34 times sine of pi over 6, replacing the x with 5, and I'll just simplify the inside of the parentheses. 5 minus 4.3 is 0.7. And you can plug this in the calculator. Make sure that you are in radian mode, since this is in radians. So you go 34 times sine, and then in parentheses, pi divided by 6 times 0.7. And I got approximately 12.18. And it looks like we have 2 significant digits, so that would be 12 degrees. So 12 degrees Fahrenheit is the average temperature during the month of May. And part C, what would be the approximation for the average annual temperature at Mold Bay? If we think of the graph, how the middle is the x-axis, and that represents 0 degrees, so the average annual temperature would be 0 degrees. Goes above and below that, but that would be the middle of the graph.